Hi, welcome back to college trigonometry. And as you already know, I got a message from the math department, and they say that we have to switch to online class because of the virus. Yeah, I know that to some of you it's very hard for you to interact with each other. Because there's no way we can interact with one another except that we can post the question through Canvas, and I can answer the question on Canvas. That's the only change. And I don't think that when we switch to the online version lecture, this would be too hard though, because it's not really hard for me because usually I already post this the video for you guys to watch the solution. So I want you it just require you to check your Canvas message all the time. And yes, and you should, because you know, now we have virus. And make sure that you want to check the updated information from Valencia College or from me. So yes, so please check your Canvas message all the time. Okay. um, let's see. So regarding the test, I already graded. I already posted the solution. I already put a solution, and I already posted the grade online in my MATLAB, so you can go on ahead and check. Regarding assignment number 5, so please you can uh, I already mentioned in the previous email. I say that it's due on March 29th, and I said that you can send me through email. But I mean, right now I just recently sent you another message on Canvas, and I say that you can submit that under the assignment tab, assignment number 5 tab. But in order to be able to finish all the question on number 5, yeah, we have to go through the lecture today. Hold on, let me check the focus. Let me focus this a little bit, you know. There you go. Yeah, so uh, one more thing, that's I'm really sorry because I still have my allergy, and you see that I have my medication around with me over here. So, and it just have a little bit, but it's not too much. So just bear with me for the next few hours, okay? I tried to finish the lecture on the new concept for maybe 1 hour and 15 minutes only, the same way as I do in class. So it's not gonna take too much time, and I will continue posting the new lecture until we getting back to our real classroom on March 30. Okay, so if you guys have any questions, just let me know. Give me the message on Canvas. All right, let's get started. So so far we been learning a lot of things. We learned trigonometry ratio. We learned a bunch of formula, property, and we learned how to simplify it. We learned how to find the inverse of the trigonometry function. And those things, those information is very important. Those knowledge is so important because it will help you to do and to understand the concept I'm doing today in this video. As you already learned in college algebra, you learn how to solve different type of equation. For example, you learn how to solve a radical equation, the equation that contain radical. You learn how to solve an absolute equation, which is the equation that contain absolute symbol. You also learn how to solve what else? A quadratic equation, right? Quadratic equation is very important. I'm sorry again. It's okay. And you also know in college algebra that um, solution of the equation is actually the intersection point of the graph of its graph with the x-axis, right? So if we have one intersection point, it means that we have one solution. If we have two intersection points, for example, in quadratic equation, we have two intersection points. It means we have two solutions. However, if you go back and take a look at trigonometry function, the graph of trigonometry function, for example, the sine function, excuse me, the sine function is going up and down all the way to the right hand side, right? And it's go up and down all the way to the left hand side. It contains many intersection points. And because it contains many intersection points, it means that we have infinite many solutions. We have a bunch of the solutions. And when we have a bunch of solutions, we cannot just say that the solution of this equation is like x equal to pi over 3, excuse me, or x equal to pi over 6, okay? But we must be able to um, obtain the general solution, unless the question that asks you that, okay, they just want the solution between, for example, between negative pi over 2 and pi over 6, something like that, and you just pick a few solutions, few intersection points between them, okay, between negative pi over 2 and pi over 6. If there's no intersection point between that interval, then we don't have the solution. Other than that, if they don't put the restriction on a certain equation, then you must be able to express the solution in in general form. Okay, the expression that that it can tell that the expression that it can that that you can um, obtain many solutions as you want, as you replace the k value, which is I'm going to talk about that later, with a certain real number. Okay. Okay. But before, in order to solve trigonometry equation, that's the only difference between trigonometry equation and algebraic equation we learn in college algebra. And in order to solve trigonometry equation, other than be able how to find the inverse of the trigonometry function, you must be able to you have to memorize all the cases we already learned over the past 2 months. Okay, I remember that one. There are 4 cases I give you in a lecture note. So let's start our new concept today with the recall. Okay, with the recall. Okay. Okay, so if you guys remember, in case number 1, I give you in the lecture note, when we the case number 1 is the first quadrant. Okay, first quadrant, when we have a reference angle and an angle, the original angle in the first quadrant, so theta equal to theta prime. Theta prime is the reference angle, and theta is the angle we want to find. Okay. For case number 2, case number 2 is when we have um, the terminal side on the second quadrant. Okay, and this will be our theta, and this is our theta prime. So in order to get the theta, right, so you take pi, so theta will be pi minus theta prime. Okay, just matter, the whole thing is pi, it's flat angle is pi, you subtract the theta primes, give you theta. Okay, that's case 2. And case number 3 is when we have terminal side on the third quadrant. Okay, it's our theta, and this is our theta prime. Okay, so in order to the relation between theta and theta prime will be pi. Okay, another pi. So theta is actually pi plus theta prime, right? Pi plus theta prime. So theta prime like that, right? Theta prime like that. So pi is from here to here. Okay, you take pi, you add to theta prime, it give you theta. Okay, it's common sense. Okay, that's case 3. And case number 4. Case number 4. For case number 4, we have a terminal side on the last quadrant. Okay, this is our theta. and this is our theta prime, and the relation between theta and theta prime will be 2 pi. So theta will be 2 pi minus theta prime. Okay, just a common sense. So you say you want to get from here to here, you take the whole revolution, right? And you subtract by theta prime. So they give you from here to here. Okay, 2 pi is a whole revolution. 2 pi is a whole circle. You take a whole circle, you subtract this piece, and it give you this little piece here. Okay, you subtract this piece, and give you the whatever left. Okay, so all these 4 cases is so important, because if you don't remember this, if you cannot memorize this, okay, then there's no way you can solve trigonometry equation, even the simple trigonometry equation. Okay, so I'm gonna use the concept here, all 4 cases here, to start out a new concept today. So the topic we want to do today is we want to solve trigonometry equation. Okay. All right. So trigonometry equation is very high equation. Okay, it's not like the equation you already learned in college level, in college algebra. Trigonometry equation, I want it hard. It's very hard. But in this course, we're not gonna do something like crazy thing. Okay, we just do the standard or something in the textbook. Um, and by reading the textbook, I realized that I can categorize it. No one can categorize this for you. I categorize it into 2 or 3 type of trigonometry equation. The first type of the trigonometry equation, I can call this the basic one. So let's talk about type 1. Okay, basic trig equation. Okay, so the strategy to solve basic trig equation is we're going to use uh, one of the cases over here. One of the cases over here. Okay, and as long as you know how to solve basic trig equation, you can move a little bit higher to solve something harder. Okay, that would be in type 2, and another type I'm going to call it general type, when it's not in type 1 and type 2. However, you have to reduce that type, type number 3, or maybe the advanced type, to type 1 and type 2 to solve for the solution. Okay, so the basic trigonometry equation is the equation that contains only one trigonometry function. On the left hand side, on the right hand side, you will have a value. For example, I have sine of x equal to square root of 2. Okay, or I can have something like cosine of x equal 1 over 2, or tangent of x equal to square root of 3 over 3, something like that. Only one equation, only one trigonometry function on the left hand side. Okay, then I call the basic trigonometry equation. Okay, so in order to solve this, our first step is the first question you need to ask yourself. Okay, the first question, which is you need to know what quadrant do you want to consider? Okay, answer 1. So by looking at the value on the right hand side, I see that will be square root of 2 over 2. So sine is positive. Sine of x is positive, and sine is positive. I know the quadrant I want to consider will be quadrant 1 and 2. Okay, so after you know the quadrant already, question 2 is what cases, okay, do you want to use? Okay, answer. Of course, because this is quadrant 1 and 2, so you're gonna use case 1 and case 2. Case 1 and case 2. Okay. Of course, when you solve trigonometry equation, you're not going to go ahead and list all the question and the answer like that, right? But this is the strategy. This is what I want to show you how the brain is working, okay? How the brain is working to get to the final solution, okay? So you know case 1 and case 2. And you know sine is positive. That's what you learned, you know so far. Okay. So you have to think, okay, let's do a recall. I had to go back to, because this is case 1 and 2. So let's do case 1 first. Okay. For case 1, you have to think about a special angle. Okay, the special angle that when you take sine, it gives you square root of 2 over 2. And the special angle must be 45 degrees, right? Or pi over 4. Okay, it's pi over 4 or 45 degrees. So there's two ways to express the solution. You can express in terms of radian, or you can express in terms of degree. So I just go ahead and express in terms of radian. Okay, so you know the sine of pi over 4 give you square root of 2 over 2. Okay, so my solution will be x equal to, okay, pi over 4. Okay, however, because sine function is periodic function, okay, so there are many other angle that also give, when you take sine, that also give you square root of 2 over 2. Okay, so you have, and you also know that the period of sine is 2 pi. So you, in order to get the general solution of case 1, my x value, the solution will be pi, x equal to pi over 4. You have to add to 2k pi. Okay, 2k pi. When k is equal to plus minus 1, plus minus 2, and so on, and 0 also. Okay. And why I have to write like that? Because when k equal to 0, 2k pi is 0, so you have x equal to pi over 4, which means one of the angle. When you take sine, pi over 4 give you square root 2 over 2. When k equal to 1, so 2 pi plus pi over 4. 2 pi plus pi over 4, you do the mental by 2 pi plus pi over 4 is 9 pi over 4. When you take sine of 9 pi over 4, it's also give you square root of 2 over 2. So we have infinite many solutions, okay, corresponding to each k value here. So we have a bunch, we have infinite many value of k here. We have plus minus 3, plus minus 100. So we have a bunch of solutions. Okay, we have infinite many solutions. Okay, and for case 2. So this is the general solution of case 1, okay? So for case 2 right here. In order to get the angle, you subtract pi from the reference. You subtract pi from the reference. And we know that in case 1, the reference and the original are the same. So in order to get the solution, you take pi minus pi over 4. Okay, pi minus pi over 4. Okay, and again, you still have to add 2k pi over there, because it's periodic solution. The k value will be 1, 2, 2, 3, 4, 5. So on the test, okay, if I want you to solve on the assignment, I just want you to solve when you get the solution. I just want you to write one time k equal to 0 plus minus 1 plus minus 2. Then I know this is give you 3 pi over 4 plus 2k pi. There you go. And I successfully obtain two general solutions for this equation. Okay. All right. So remember that you need to add 2k pi into the solution. Okay. Let's do another example. Still type 1. Okay. Example 2. What if I have cosine of x equal to 2? Okay. How am I going to solve for x? You know that if you remember the graph of the cosine function, the range is between -1 and 1 only. But right now, we have 2. So this is outside the range. Cosine must be between -1 and 1. But 2 is outside the range. So if it's outside the range, I can jump to conclusion, right, where there's no solution. Okay? The same thing when you deal with sine. If sine of x equal to 3, and you know the range of sine of x is between -1 and 1, so you know the sine equal to x equal to 3 is outside the range, then you can jump into the conclusion that there's no solution. Okay? Example 2. Example 3. Let's do something with tangent, okay? For example, I have tangent of x equal to a negative square root of 3, for example. Negative square root of 3. Again, so again, the question you want to ask yourself, you need to know what quadrant tangent negative. Okay? You ask yourself the same kind of question here. Same kind of question here. Okay? What quadrant the tangent negative? So the tangent negative in quadrant 2, quadrant 2, and 4. Alright, tangent negative, quadrant 2 and 1, because tangent is sine over cosine. Okay, so if one of them is negative, so this gives you negative. Okay, it's tangent negative, so quadrant 2 and 4. And after you know quadrant 2 and 4, you know the case. It could be case 2 and case 4. Okay, case 2, okay, and case 4. Okay, case 2 and case 4. Alright, so after you know the case 2 and case 4, then we can get the general solution. Case 2 and 4, we can get the general solution of the x that when you take tangent, give you negative square root of 3. Right? Okay. Alright, so you know case 2 and case 4. So let's do case 2. Okay, case 2. Case 2 is when we have theta minus, we have theta prime reference angle subtracted from pi. That's case 2. Okay, so we know case 2, and we know the original. You know the. Okay, let me write it over here. Tangent of x equal negative square root of 3. Case 2 is theta equal to pi minus theta prime. Okay, so in order to get the x here, you have to think about the reference angle. Okay, that reference angle, when you take tangent, not the reference, original angle, when you take tangent, give you square root of 3. So you always, because you see, in order to get case 2, right? Case 2 is related to the theta, and theta is in case 1. So in order to get to case 2, actually, this you have to go back to case 1. Oh, but it's our focus again. This is crazy. There you go. Okay, you have to go back to case 1. Okay, and case 1 is tangent is positive. Okay, so we have to go back to case 1 also. Always start with that. So you know tangent of x equal to negative square root of 3. We notice case 2 and case 4. Now we got to go back to case 1, which is tangent positive. Okay, you need to think about what angle, when you take tangent, give you square root of 3. Okay, so tangent, the angle, when you take tangent, that give you square root of 3 must be pi over 6. Must be pi over 6, right? Because pi over 6 give you square root of 3, right? I don't think I get the careless mistake over there. Um, Tangent of pi over 6, I mean tangent of 30 degree, right? Tangent of 30 degree give you is that square root of tangent of 30 degree? Or maybe square root. Oh, I think I had to get this. So this I think pi over is this pi over 6 30 degree or 60 degree. I'm sorry, tangent of 60 degree. Okay. So it's tangent of 60 degree, not 30 degree. So tangent is pi over 3. Okay. Tangent of pi over 3 give you a square root of 3. Okay, tangent of pi over 3. Tangent, we know. Okay, I'm going to write over here. We know that tangent of pi over 3, which is tangent of 60 degree, give you square root of 3. Okay, you know that. Tangent of 60 degree, right? Tangent will give you square root of 3. Okay, 60 degree is 180 divided by 3 is 60. So tangent of pi over 3 give you square root of 3. Okay, but we don't want quadrant 1. We want quadrant 2 and 4. We want quadrant 2. So in order to get quadrant 2, okay, you subtract it from pi. Okay, so my x will be pi minus pi over 3. Okay, plus, okay, we need to get a general. So the period of tangent is not 2k pi. It's not 2 pi anymore, just pi. So instead of added to 2k pi, you just add it to k pi. Okay. So your answer will be 2 pi plus k pi. Okay. So it's very important when you have the negative value on the right hand side, because you still have to consider quadrant 1. Okay, you still have to consider quadrant 1. Okay, the original angle. So this is the solution. Okay, case 4. Case 4, we subtract from 2 pi. Case 4, we subtract from 2 pi. It's out of focus again. Case 4, we subtract from 2 pi. Okay, so my solution will be, my general solution will be 2 pi minus pi over 3. Okay, you 5 pi over 3 plus k pi. Okay, so here you go. I got successfully 2 general solutions, case 2 and case 4. Okay, so this is what you have to remember. You have to go back to the first quadrant when the value on the right hand side is negative. Okay, if the value on the right hand side is positive, then okay, this will be easy. Okay, but when you have a value on the right is negative, you still have to go back to the first case, the case number 1, which is the first quadrant. Okay, like example number 3. And let's see, what if I give you another basic one, cosine of x equal to, so in this case, instead of equal to a special value like square root of 2 over 2, 1/2 square root of 3 over 2, I'm going to give you something like, it's not special. For example, I have something like 1 over 3. Okay, 1 over 3, if you look at a table, right, there's no value of angle that's give you cosine 1 over 3. Okay, so in this case, you're going to apply the same thing. Okay, you apply the same thing. So cosine, we know what quadrant, cosine positive, quadrant cosine positive. Cosine is positive. So cosine positive, quadrant 1 and 4. Okay, quadrant 1 and 4. So it will be case 1 and 4. Okay, case 1 will be easy. Okay, case 1 will be easy. Alright. Case 1, the reference angle, the original angle is the same. Okay, so for case 1, you see that because 1 over 3 is not special. So you cannot refer to the unit circle, you cannot refer to the angle value I give you. So in order to get the solution, you take inverse of that. So you take inverse of 1 over 3. And again, you still have to add 2k pi. Okay, and inverse of 1 over 3, you can put the inverse of 1 over 3, right, into the calculator. Okay, then it gives you the angle value in degree or in radian, but you don't have to. You just go ahead and leave it like this, and I'll take credit for that. So that could be the general. And case 4, case 4 is you take 2 pi minus, okay, 2 pi minus, so the x will be 2 pi minus the original angle, right? Minus the reference angle, okay, okay, okay. So they give you 2 pi minus inverse cosine of 1 over 3. It's the original angle right here, the reference angle right here, okay, reference angle right here. Okay. Again, you have to add 2k pi. There you go. And you have two general solution. Okay. And let's go back to example number 3 really quick. What if they want you just to get a couple solution instead of get the general solution? What if they want you to get it between a certain interval? There you just need to replace k with the you need to replace k with the corresponding integer, positive 1, 2, negative 1, 2, and so on, so that you have it inside the interval if they give you the restriction on the solution, okay? But most of the time, I don't know, maybe in the assignment I give you the restriction. If I don't give you the restriction, you just need to get the general solution like that, okay? All right. All right. So far, so good. So that is type 1, okay? That's type 1. Okay, so now we're gonna just assume that you know how to do type 1 already. So we're gonna jump to type 2. So in type 2, the goal, the strategy is, in type 2, the strategy is you need to apply the GCF. Okay, you need to know how to factoring. Okay, okay, and you must know how to convert into quadratic form sometime. Okay, one of this strategy. Okay, because when you convert into quadratic form, x squared plus bx plus c, then you can factor, right? And you can factor, and you can use the zero product property. Okay, so this is the tool. It help you to solve trigonometry equation of type 2. Okay, let's consider one of the solution. Let's see. How about this? Example 1. Okay. How about I have 2 sine square x plus sine x equal to 0. Okay. All right. So let's analyze this question. So you see over here that my equation is look like in quadratic form, but it's not full standard form of quadratic equation. So because it's not in full form, so what I have to do is I just find the GCF. Okay, and I apply the zero product property. So the GCF between these two terms, I take psi out. So what I have left inside is 2 psi, right? Okay, because psi times psi is psi squared. Okay, and over here will be 1 equal to 0. Now I'm going to apply the zero product property. And you see that this time this equal to 0, then psi of x equal to 0, or 2 psi of x plus 1 equal to 0. Okay. Psi of x equal to 0. Okay. 0, psi of x equal to 0. So this is in quadrantal position. It's in quadrantal position. This is unit circle like that, right? This is my psi. Okay. This is 0 right here. So psi of x equal to 0. Psi of x equal to 0. It's in quadrantal position. Okay. So the answer must be what? The answer must be, if you remember, you refer to the special angle. Okay. What angle of sine it give you 0? It's only 0, right? One of them. It's just one of them. Another one is what? 0. Okay. The angle is 0, and the angle is pi. If you refer to the table. Okay. But again, sine is a parallel function. So you have 0 pi, and you go back to 0. Okay. You have the angle 0. You have angle pi. So you see that. Just imagine you rotate it. So this is 0 angle. You rotate it over here. At pi. Then go back here. 2 pi, 3 pi, 4 pi, 6 pi, 7 pi. Oh, then my general solution x will be 2k pi. Right? With k is 0, plus minus 1, plus minus 2. Because we can go backward. Sine of negative pi is also 0. Right? If you replace k is equal to negative 1. Okay, so if you replace k equal to negative 1, your sine of negative 2 pi is also 0. Okay. Okay, so this will be the general solution. Sine of x equal to 0, x will be 2k pi. Okay, all right. This one we need to do one more step in order to bring it to type 1, the one we just recently talked about. So it's 2 sine of x equal to negative 1. Then sine of x equal to negative 1 over 2. Okay. Negative 1 over 2, sine negative quadrant 3 and 4. And again, we always have to go back to quadrant 1. Okay? Sine of what angle give you 1 over 2? Okay, will be 30 degree, right? 30 degree is pi over 6. And we want quadrant, this is quadrant 3 and 4. So case 3 and 4. Okay. All right. And you know sine of pi over 6 is 1 over 2. But because we want a quadrant 3, case 3, so my answer will be pi plus pi over 6 plus 2k pi. Because pi over 6 is 30 degree. It's 1 over 2. So the answer will be 7 pi over 6 plus 2k pi. Okay, that's just one of the general solution. And another solution will be case 4. In case 4 will be 2 pi minus pi over 6 plus 2k pi. So the answer will be 11 pi over 6 plus 2k pi. There you go. Then you have two solutions. And if the question just want you to restrict your solution in certain interval, then you can replace the k value correspondingly. so that your x value is inside that interval. Okay, so there's no restriction here, so I'm not gonna go ahead replace the k. Okay, so I just leave it like that. Okay, all right, let's do another example. Okay, how about something like this? How about I have, oh, let me refocus them. Oh my gosh, I hate it, you know. It's always out of focus, you know. Okay, it's still out of focus. Strange. Okay. Let me write a question first anyway. So you have a sine squared of x equal 5 plus 10 cosine of x. Oh my god. There you go. Oh. So you see that in this equation, you see it's not in type 1 because it contain more than one function. We have sine, cosine, we have number 5, so it's not type 1. Okay, and if you recognize it, it must be in type 2 because it looks like it's in quadratic form. Okay, I don't know if you can see that. You see the sine square. If you do you apply the property in the Pythagorean identity, you see that sine square is 1 minus cosine square. Okay, and I distribute it. Okay, so I see that this is quadratic form. Okay, so I reorder them. Okay, they give me the equation that is in quadratic form, right? It is quadratic form. And because this is quadratic form, we can factor them. Okay, I'm sure you guys know how to factor this, so I'm going to go through this really quick. So they give you 2 cosine of x plus 3, and this will give you 4 cosine of x minus 1 equal to 0. Now you cannot tell me that you don't know how to factor a quadratic function, okay? So if you forget how to factor, please go back to college, review college algebra. And I know sometimes you guys forget, you learn and you guys forget. Let's go back and review it and you should be okay. But the most important thing, you must be able to recognize this in quadratic form. Okay, if you don't recognize it in quadratic form, then you don't know it's quadratic form, then you don't do the factoring. So after you factor, you apply the zero product property. So you split them up. Okay, okay, and for this one, you subtract both sides by 3 to bring it back to the basic form over here. You bring it back to the basic form, 1/4, right? Okay, so you see with 3 over 2 is 1 over 2, 1 over 5, which is outside the range. And when it's outside the range, it's outside the range. And because the range is between 1 and 1, so it's outside, so no solution. Okay, because it's outside. 1 over 4 is inside the range, but this is not special value. It's not like 1 over 2, square root of 2 over 2, it's not square root of 3 over 2, right? So it's not special value, and because it's not special value, we gotta use the inverse notation. Okay, again, cosine positive quadrant what? Quadrant 1, 4. Okay, so we case 1, 4. Oh, not 1, 4, it's oh yeah, 1, 4. I'm sorry. Okay, so the solution will be what? It's 1 over 4. So the solution will be case 1. So it will be inverse because it's not special angle. So we have to use the inverse 1 over 4 plus 2k pi, which is case 1. And case 4 will be 2 pi minus cosine inverse 1 over 4 plus 2k pi. There you go. Then it gives you the general solution. So you see that we always have to go back to case 1 no matter what, though. Okay, of course when it's positive you don't have to there's nothing much talk about. And when you have negative, you still have, when the value is negative, you still have to go back to case 1. Okay, all right, let's see sometime let's see. Let's do another one because sometime I don't think I should talk about another case when I think we should learn only 2 cases, which is you move back to the factoring method or G-shape to solve trigonometry equation. Okay, for example here, let's do another one. Okay. What if I have like this sine of 2x equal to sine of x, and now I want to apply the restriction on my solution. So I want the solution between 0 and 2 pi only. Okay. Okay. So by the first observation, you see that over here this is not in case in type 1 because type 1 is the standard one. Okay, the basic one. We always have to go back to the basic one. Yes, at the end, though. But over here it's not type 1. It might be type 2. Okay, but in order for them to be in type 2, you have to do some manipulation a little bit. You know that sine of 2x is 2 sine of x cosine of x. Okay, and you subtract both sides by sine of x, then you will have this. Okay, to subtract both sides by sine, you have this. Some students just cancel the I sine. It doesn't work like that. Okay, don't do like that. Don't cancel my. Just move everything to the left hand side or to the right hand side and let one side go to 0. And you see that they have G shape, so I factor them out. And now you see that in type 2, and you can apply the zero product property. Okay, sine of y equal to 0, so x would be 2k pi. I already talked about that last time in the previous example. Cosine of x equal to a half, right? Add both sides by 1 divided by 2. And now cosine positive is a quadrant 1 and 4 again. So this is case 1 and 4. And because of this is a special angle, which is good. So what angle give you 1 over 2? It just pi over what? 1 over 2 is pi over 3, right? Okay, plus 2k pi. And case 4 will be 2 pi minus, so it will be 2 pi minus pi over 3 plus 2k pi. Okay. But you have to look at the restriction. We want between only 0 and 2 pi only. So if we write the solution in general form like that, then it's not really good, right? It's not quite, because we want only between 0 and 2 pi. So let's see which one over here. If k equal 1, it works, right? If k equal to 0, it works. Then k equals 0, if x equal to 0 and k equal 1, if x equal to 2 pi, it works. So between we want to include 0 and 2 pi. Okay, you cannot do k equal 2 because if k equal 2 give you 2 times 2, 4 pi is outside the range. Okay, it's outside the range. If k equal to negative 2, give you negative 4 pi is less than 0, it's outside the range. Okay, so this answer here is just 0 and 2 pi. Let's do here. If k equal to 0, it works, right? Because if k equal to 0, So my solution is just x equal to pi over 3, and pi over 3 between 0 and 2 pi. It works. If k equal 1, so pi over 3 plus 2 pi, so it's more than 2 pi. So it doesn't work. So k equal 1 doesn't work. So we just pick the k value so that the x value is inside the interval. How about over here? Oh, let me finish. This give you 5 pi over 3 plus 2 k pi. Okay, equal 1. K to 1. It work now? K to 1 doesn't work because k equal 1 give you 2 pi. Add this is outside the range. If k equal to 0, it works because it works now. 5 pi over 3. If k equal 1, x equal to 5 pi over 3. 5 pi over 3 is it between 0 and 2 pi? Yes, it is. Because 5 by 5 divided by 3 give you 1 point something in between. So my solution will be this, 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 this. So there are only 4 individual solutions after I apply the restriction. Okay. All right. So I have to say this, okay? In order for you to be able to solve trigonometric equation, first of all, you have to memorize all the cases. You must know this, okay? This image here must be in your brain. You can, if you don't remember it, if you cannot memorize this, then you know where you can solve, okay? Secondly, you must memorize the special angle. If you don't memorize the special angle, it does not, it doesn't work. Because if you don't memorize special angle, you cannot refer to the quadrant 1. You see that? You cannot refer to quadrant 1. Number 3, you must be able to, you must memorize all the trigonometry identity. You see it over here in the example here. We don't use much trigonometry to simplify. The thing is that some equation is not in the form of type 1 and type 2 right away. Okay, you need to simplify, you need to manipulate, you need to do something, some way, somehow, so that you can bring it back to type 1 and type 2. Okay, and even type 2, even you bring it back to type 2, it always go back to type 1. Okay, you gotta look at it. This is type 2. This is type 2. Okay, type 2. And it's always go back to the basic form like that. Okay. So your goals is to bring it back to type 2 to type 1, or at least to type 2, which is so that you can bring it back to type 1 to solve the equation. Okay. All right. Alright, let me see. So this will be the lecture for section, let's see, so for section 6.2 and 6.3, homework already been assigned, it's already been open for you to work on. Hopefully that after the lecture you should be able to solve the assignment number 5. Okay, I know that because of the virus, the Valencia closed and you guys don't have a chance to talk to the tutor in the math center. So I really recommend you guys to contact each other on the phone, okay, talk to each other, call each other, okay, and figure out, you can Skype, you can Skype so that you work together, collaborate, so that you can figure out this answer for the solution for the equation. Okay. I try to cover as much as I can, but because you see that because of virus, we've been falling behind 2 weeks. So I might, as I said in the email, I might throw away one of the assignment. I think you like it, okay? And maybe I might skip one of the session, the one that is not really important, okay? But it's still inside our curriculum. But let's see. but throwing away one of the assignment, yes, maybe. Okay. But I'll try to see like we can cover as much as we can or not. All right. All right. So I think that's all for our lecture today. Please go. I want you to watch this carefully. Post your question on the discussion board on Canvas. Okay. Then I'll try to answer if you guys have any concern or anything you don't understand. Um, I will help you with that. Okay. Um, I can give you a hint on the assignment also. Okay. Yeah. So yeah, I have a great confidence that we will overcome this challenge. Um, I know some of you guys don't, like online lecture, but that's what we have to do at this moment. Okay, so yes, so go ahead, email me, ask any question. Don't hesitate asking any question, and watch it again. The most important, watch the video, and I'll see you next time on the next video. All right, thank you so much. Bye bye.